Hi students, welcome to my YouTube channel. So this is the structured essay discussion of 2023 October paper. So we'll see the first one. Explain the general trend in first annexation energy across period 2. So when they ask for the general trend, you have to know what you can observe generally, not the actual one. So we can see 500, 900, 1000, 1004, 1006, right? 2000. Generally, it's increasing. So you can write there is an overall increase in the first annexation energy. The reason is the number of protons are increasing across the period. And also, you have to mention, children, when they are in the same period, they will have the same number of outer electrons or same energy level, right? So the second mark is given, but the electron removed comes from the same quantum shell. But the electron removed comes from the same quantum shell. So when they come from the same quantum shell and when the number of protons increases, outer electrons get more attracted to the ones with the higher number of protons. Therefore, the annexation energy increases. The energy we need to give to remove an electron will be greater as they are attracted more to the nucleus. Predict a value for the first annexation energy of oxygen. For that, children, you all need to know that annexation graph. This is a normal way. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So you can see normally than nitrogen and fluorine, oxygen should be lower. So they have given a range from 1200 to 1350. So you can write anything between that. The second annexation energy of lithium is given. Write the equation. So that means we are removing the second electron from a gaseous ion that has already removed the first electron. So it should be written like this. So children, in the previous one, after writing the annexation value, you have to justify your answer. So if you take oxygen, right, we know oxygen is 8, 1s2, 2s2, 2p4. So if you take the p subshell, 1, 2, 3, 4, it has a paired orbital. So when you have paired orbital, there are repulsions between the electrons. Therefore, it's easy for us to remove the electron. So after writing the annexation energy, you have to mention in the 3p subshell, it has a paired orbital. Due to the greater repulsions, easy to remove the electron or less energy is needed to remove the electron. Then I explained the B1. Now B2, explain the large difference between the first and second annexation energies of lithium. So we know, children, lithium is 3, 1s2, 2s1. So first electron is removed from a 2s subshell, which is far from the nucleus. Second electron is removed from a stable electronic configuration or from a full shell. So we need to give more energy and it is also closer to the nucleus, right? So in the marking scheme, they have given second electron is removed from a inner main energy level or from a lower main energy level. 1 mark. Removal of an electron needs more energy as it is attracted to the positively charged nucleus. It needs more energy. Removal of an electron require more energy as it is closer to the positively charged nucleus. So we have to draw the dot product diagram of molecule BeCl2. So it's beryllium chloride. Beryllium is 4, 1s2, 2s2. In the outermost shell, you have only 2 electrons and both will form bonding with chlorine. So it's a linear molecule. So this is how you have to draw it. 2 bond pairs, 0 lone pairs, it's linear. Explain the shape. So I said it's linear, bond angle is 180. Explanation, 2 bond pairs, 0 lone pairs. They form the linear shape to minimize the repulsion between the electron pairs. Draw the diagram of Be2Cl4. So the only way we can draw it so that the 2 beryllium atoms are having this is the only way you can draw. Because each BaC beryllium should have 2 chlorine and there should be a dative covalent bond forming between chlorine and beryllium. So this is the only way we can draw to show it. Type of bond is dative covalent bond where the lone pair on chlorine is given to the electron deficient beryllium. The energy density is the amount of energy released per kilogram. Calculate the mean energy density of this E10 fuel in megajoules per kilogram. So to find the mean energy, we know a brand of E10 was containing 92.2 hydrocarbons and 7.8 ethanol by mass. So for ethanol, they have given the density that is for 7.8. For this, the density is given as 46.5 megajoules per. So to find the mean energy, you need to multiply 46.5 by 92.2 and 29.7 into 7.8, divide both by 100. So you get the energy density as 45.19, which is closer to 45. Appropriate number of significant figures. So I took it as 45 megajoules per kilogram. The density of the E10 fuel is 0.729. Calculate the mass of 1500 of the fuel. Density is given by mass over volume. Mass is equal to D over V, which is 0.729 into 1500. You get the answer as 1093.5 grams. Calculate the energy released when 1500 of E10 fuel is burned in excess oxygen using your answers from A1 and A2. Okay, so we found the mass of the fuel as 1093.5. That is for per kilogram, right? So if you want to find in grams, 1093.5 is for megajoules per kilogram. Then for grams, you have to multiply by 1000, you get it in 1.0935 grams. Mean energy, we got the mean energy as 45.19. So this is in megajoules then. Then the total energy for that will be 1.0935 into 45.19, 49.415 megajoules. This is in grams, this is in megajoules per gram. Then you can find the energy in megajoules. So this is the energy released as the unit of energy is in joules. Many countries are gradually replacing E5 fuels with E10. Explain how this change might result in a more sustainable fuel. So if you compare E5 and E10, we can see in E10, it has 92.2 hydrocarbons, 7.8 ethanol. In E5, 5% ethanol and 95% hydrocarbons. So when you use E10, the use of hydrocarbon has reduced, and the use of ethanol has increased. And you know, ethanol is a biofuel, or it can be regenerate. We can get it from plant sources as well. So in the marking scheme, they have given ethanol used could be bioethanol, or ethanol sources are from plants, 1 mark. It can be easily taken from fermentation. So ethanol, you can get it from fermentation. Reducing carbon dioxide emissions overall. So than taking 95% hydrocarbons and 92.5% hydrocarbons, we can see the carbon dioxide emissions will be reduced. Less impact on global warming. Use less of a finite resource. Less pollution from sulfur impurities. So the idea you have to mention that they have increased the percentage of ethanol, and ethanol is it can be regenerate, and also it's a bioethanol. So it reduces the emissions of carbon dioxide, right? Global warming, reduces global warming. Those things you can write. Write the equation for this using the molecular formula. The straight chain hexane. Hexane is C6H14. Will form a cyclic. Cyclic means C6H12 plus hydrogen. Draw the structure of the cyclic hydrocarbon. So you can draw cyclic hydrocarbon contains a ring of 5 carbons only. Then we should have a branch chain because cyclohexene has 6 carbons. So 1, 2, 3, 4, 5 with a branch chain. Hexane will react with chlorine in the presence of UV light. Describe the role of the UV light in the initiation step of this reaction. So what will happen? Chlorine will undergo homolytic fission to form two chlorine radicals. In the marking scheme they have given, UV light provides enough energy to break CCl bonds by homolytic fission, 1 mark, to form chlorine radicals, or you can write the equation. If you write Cl2 becoming 2Cl radical also, you get marks. The alkane dodecane is formed in this reaction. Write equation for the propagation step and for the termination step. So normally we know when an alkane undergo free radical substitution with a chlorine radical, one of the hydrogen atoms will be replaced and it will form HCl. So C12H25 radical will attack a chlorine molecule to form C12H25Cl and Cl radical. For termination step, you can take the combination of 2 chlorine radicals or C12H5 and C12H5 H25 to give C24H50. So in the marking scheme, any one of these are correct. For each reaction, 1 mark. Then the 20th one, a straight chain alkene has the structure shown. Draw the skeletal formula of the 4 structural isomers of X that are alkenes. Do not include geometric isomers. Okay. So you can draw the double bond here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then I can put a branch chain. 1, 2, 3, 4, 5 and a double bond. Another one I can 1, 2, 3, 4, 5. I can put branches only. 1, 2, 3, 4. One, 2, 3, 4, 5. Then another one I have to draw. One, 2, 3, 4, 5. Yeah, so these are the only 4 structures I can draw. Explain why X can exist as geometric isomer. So you mentioned about the limited rotation of the double bond and that one of the carbon in the carbon-carbon double bond shouldn't have identical group. So in the marking scheme they have given there are 2 different groups on each of the carbon atoms in the carbon-carbon double bond and the carbon-carbon double bond has restricted rotation. So when you write the name of this 1, 2, 3, 4, you can write it as and also you can see geometric isomers are there. The 2 higher priority groups are on the opposite side. So it should be 2E, 2, 3 dichloro butane. Bute 2-ene because it's a alkene. A student stated that compound Y has polar bond, so it's a polar molecule. Comment on this statement. So this part is correct. It has polar bond because there is an electronegative difference between carbon and chlorine, as chlorine has a higher electronegativity. But it is not a polar molecule because these 2 chlorines will pull electrons in the same using the same force. Therefore, it will cancel out. It's a non-polar molecule. In the marking scheme they have given, the student is correct that the alkene has polar bond because CCl bonds are polar, 1 mark, as Cl is more electronegative than carbon, 1 mark. But the molecule is non-polar as it is symmetrical or it has 0 dipole moment or it has even distribution of charge. Bisabolines are a group of compounds found in plants and fungi. Calculate the amount of moles of bisabolane in 5.51 grams divided by 204. So when they give a different name or compound, no need to get scared. If they give a mass, the only equation we can use to find the number of moles is this. So when you divide 5.51 by 204, you get it as 0.0270 moles. Calculate the amount of moles of hydrogen that reacted with using the ideal gas equation. So to apply the ideal gas equation, pressure should be in Pascal. It's correct. Volume should be in cubic meters. Here they have given in cubic centimeters. So we need to convert. For these conversions also you are getting marks into 10 to the power minus 6 cubic meters. Then temperature should be in Kelvin. Here it's 150 plus 273. You get it as 423. Then we can easily apply to PV equals to nRT to find the number of moles of hydrogen. 152,000 into 1,873 into 10 power minus 6 divided by 8.31 into 423. So the moles of hydrogen will be 0.0809 moles. Then we need to find the number of carbon atoms. So we found the amount of alpha bisabolane as 0.02 and moles of hydrogen as 0.08. If you take the simplest ratio, we can see that it has 4 carbon-carbon double bonds. Sorry, 0.0809 divided by 0.027, not 4 then. Let's see, 0.0809 divided by 0.027, 2.9, which is equal to 3. So don't take for 2 decimal places only, your answer will be wrong. So take at least for 3 decimal places. As you are using calculators, you can take it for, better to take for 4 decimal places or at least for 3. Otherwise, if I do it if you all do as I did before, I'm getting 4 because I divided 0.08 by 0.02. But the correct answer in the marking scheme is 3. So when I use 3 decimal places only, I'm getting the correct answer. So those things you have to keep in your mind, right? Draw the skeletal formula of the monomer of polyisoprene. So to form the monomer, children, we need to break the continuation bond and the brackets, right here and here also. Then it should be a double bond. Then the correct answer is double bond, and this is the monomer of polyisoprene. A sample of polyisoprene has a relative molecular mass of 50,220. To find the amount of repeat units, we need to find the molecular mass of the repeat unit. So this should be hydrogen, 2 hydrogens. So the molecular formula of the repeating unit will be 1, 2, 3, 4, 5, C5H, 1, 2, 3, 4, 5, 6, 7, 8. That means C5H10 means 68. Then 50,250 divided by 68, you can find that there are 738.9, so roughly equal to 739 repeat units. Incinerators used to dispose of polymer have a system to remove waste gases, contains solid calcium hydroxide, and why it is finely powdered. So normally, if something is finely powdered, that is to increase the surface area. And we are using a basic hydroxide to absorb toxic acidic gases like HCl, NO2, carbon dioxide, NOx, right? To absorb toxic acidic gases and to increase the surface area. Then we'll see the last question. Calculate the relative formula mass of nickel carbonate, which is very easy. Nickel, they have given 58.7 into 3. Carbon 12 into 1. Oxygen 3 and 4, 7. 7 and okay, we'll take it as 7. 7 into 16. Hydrogen 1 into 4. Water, it's 18 for 1, 18 into 4. So when you add everything, you get it as 376.1. Calculate the atom economy by mass for the formation of nickel carbonate. Okay, so we need to find the, okay, we already found it as 376.1. That plus 3 into the molar mass of sodium sulfate, which is 3 into 142.1 into 100%. So you get it as 46.872. 46.872%. Give a reason why use of the relative molecular mass is not appropriate in A1. So we can see it's an ionic compound. Normally we use formula mass for ionic compound. So you can write because it's an ionic lattice or it has a giant lattice structure. Give the electronic configuration of nickel ion present in nickel compound. So nickel is 28. We can write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d8. From that, if you remove 2 plus, we are removing only from the outer electrons, and the outer electrons are in the 4s orbital. So this is the electronic configuration of nickel ion, 3d8. Write the ionic equation for the formation of, okay, which is very easy. We can break only the aqueous ions into aqueous compounds into ions. So when you are breaking it, you have to write the amounts of each ion also. So if you take 3 nickel sulfate, we have 3 nickel 2 plus and 3 sulfate also. Here we have 2 Na plus and CO3 2 minus. 4 Na plus, 4 OH minus. We can't break liquids, solids and gases. We can write 4 water as it is. Then we can't break the solid also. So I can write the OH4, OH2O as it is. But I can break 6 Na plus and 3 SO4 2 minus. So I can cancel out these. Then 4, 5, 6 with 6 Na. So I have 3 Ni2 plus AQ, CO3 2 minus, 4 OH minus AQ and 4 H2O liquid giving Ni3 CO3 OH4 4 H2O solid only, right? That's it. Then the last question, another basic carbonate found in minerals contain the metal element X and is formed by the reaction shown. 1.995 is reacted with sodium carbonate forming 15. Okay, we have to find the relative formula mass. So children, using the volume of carbon dioxide, we can easily find the moles of carbon dioxide. 150 because they have asked us to use the molar volume. 24,000. Then the volume of moles of carbon dioxide will be 0.1. Sorry, we can find in cubic decimeter. So we need to convert 150 cubic centimeters into cubic decimeter divided by 1000. You get it as 0.15. And in 24 cubic decimeter, you have 1 mole. Then we have to find how many moles are there in 0.15. So you get the answer as 6.25 into 10 to the power minus 3 moles. Using the moles of carbon dioxide, we can easily find the moles of XSO4. It's 1 to 2. If this is 6.25 into 10 to the power minus 3, this should be multiplied by 2, which is 0.0125. And they gave the mass of XSO4 also. So we can use the other equation. You know the moles, you know the mass, you can easily find the molar mass. 1.995 divided by 0.0125, which is equal to 159.6 grams. Relative means you don't have you put units. If they ask for molecular or formula mass, you have to put the units. So the correct answer is 159.6. Then we need to find the identity of X. So we know the formula is XSO4. It is equal to 159.6. To find for X, we need to subtract the molar masses of the atomic masses of the others. 32.1 plus 64. Then when you subtract it, you get it as 63.5. 63 is for copper. So the element is copper. Copper 2 plus. Okay, so we are done with the paper discussion, children. Thank you for joining. Subscribe my channel for more videos.